So just before Param goes back, you know, what I'm trying to convey, and it's not a very popular point of view, but I'm advocating that instead of object-oriented programming or functional programming or even logic programming, you think you become a bit-oriented programmer. You think in terms of bits. They're good. They're not going anyplace. And you know, it's not something which it's not a thing which it's not a what do you call it? Yes, it's not a fashionable thing. It's not a fad. And you know, I'm pretty certain that more you learn about bits, more you will like them. Okay? There are, again, Knut is a bit-oriented programmer. There is a very nice book, which I forgot to mention, but maybe you could show. Hacker's Delight.
Hacker's Delight.
There is a very useful book, which I highly recommend. Again, you will not Alan Kay will never buy it, but I highly recommend that you do. It's called Hacker's Delight by Henry Warren. It's nothing to do with hacking. This is basically bit-oriented programming. If you show some random page, surprise me. Okay? See what I mean? Good stuff. Very, very good. No, I'm dead serious. This is something which you want to know. Right? One of the main contributors to this book was Guy Steele, who apparently wrote 100-page correction or suggestion thing. And it's good. This stuff is very, very good. It's totally lacking abstraction. You will not find definition of total ordering or weak ordering or any ordering, but it tells you about bits. So this is one of the books which I strongly, strongly recommend. And I do not recommend many computer science books. Okay? So again, this I think is a book every programmer should have on his or hers bookshelf. I wish we had more hers here, but you know, apparently A9 is not doing well. You know, it's not, you know, it's not nice looking at you guys.
So we were talking about pair, and I think Alex mentioned
yes,
if you look at the actual standard library, you'll see that the definition of pair is really, really big. And so just to clarify, we are using examples from the C++ standard library to illustrate the things we are talking about, and we try to talk about some practical issues that you need in an industrial strength implementation. But our task is not to show you how to build an industrial strength library. There are a lot more issues that come up if you want to do that. And if you think C++ is complicated, you should go look at the header file sometime, and you will see how complicated that is. So we are not going to talk about the vast majority of stuff those people have to worry about. We are trying to talk about fundamental things that transcend languages in some sense. So, you know. Okay, so getting back to pair, seems like a perfectly nice pair. What's wrong with it? I mean, why is this?
Why aren't we done? Why does it say type name? I have a question.
Yes, why does it say type name? All right.
Is it just a type name? What do we know about T1 and T2? Do we know anything?
We know their sizes.
We know their sizes, but are there any requirements on them? Aren't there? What do we want to be able to do with the pair? Yes, that's a good question, Anil asked. What is the most simple thing we want to do with a pair? Construct. When do we construct things? Now, when we assign, we do not construct. They're different. when we declare them, and when do we copy? When we return.
We pass them to a function or we return from a
So one thing is that pair wouldn't make much sense if you cannot construct it and return it and do things with it.
So we won't be able to write this, for example, right? At the very least.
And then you would want to pass this foo around. If you want to pass foo around, what are the requirements on int and double? Yes. So there are people, and they're famous people in C++ community. They're good friends of John Kalb, and they go to all the conferences who say, therefore, we have to have a requirement copyable. I think they are misguided. Why do I think they're misguided? Of course, you could say this is spite. But maybe there's something else. I actually claim.
But I mean, copyable is one thing. We need a lot of other things from the type just to be able to write this code.
You see what he did? He wrote another thing. If something is copyable, it should be also assignable. You see, this is assignment. This is, what is this? What is this? What is it called? Default constructible. So why do I think it should be default constructible? Not just constructible. Why am I so certain? For swap, I do not need default constructibility. Temporary, I would construct out of the first one. I would claim that there is, let me come up with a very general principle. A very general principle that any code sequence which makes sense everywhere for built-in types should make sense for pair. Okay? And if we think about it, one thing which we do, we often do this. Why do we do this, by the way? We first declare and then assign. We seldom write this. But we often do, let's go back, and say if. So a very common thing which happens in life, you say, if full moon, then x equals 42. Of course, Param's code is not going to compile because he doesn't put spaces around assignment. Yes, this is much better. That will compile. It's a joke, guys. So it's a joke. So this is a common thing. You declare and do something depending. It's a common thing. It's a common, I hate the word, pattern.
And plus, so if you were to insist on no default construction, what that means is you're forcing some value to be put in, even when you know that right after that you're going to overwrite it because you don't know what value to put in right now. Right? So you're forcing more work to be done for
potentially.
You know.
And we could have a very nice, as we shall see, we could have a very nice theory on what in general default constructor should do. Let's try to develop this theory right now on the fly. It's a very nice theory. If I write t, just write tx. What do I know about x? Do I know anything, Nick? Is it equal to 0? No, I mean, t might not even have a notion of 0. What do I know about x? For sure. Yes, but all t's have the same size. So what is this particular t is guaranteed to do?
Referenceable by x.
It's destructible. That's what I know. You see, the only thing I know about this value. What do you mean one? Yes, it's a value. That is, I could do anything else. I could assign to it, so some other value, and I could destroy. All right? But, I mean, what it basically means is there are sort of, if I do that in general, I should not rely on any property except that I could either assign a real value to it, or I could get out of the scope and destroy it. Right? So it's right. But so I'm just, should a default constructor exist for pair? I'm actually going to give you a really terrible answer. It depends. On what? Yes. We're going back to, we need to have requirements on, could we go back to this code? So, if we want to have this guy to have a default constructor, the only meaningful default constructor will be just use the default constructors for first and for second. Do you agree? Therefore, we have a requirement on this thing. So we agreed that it has to have a default constructor. Now, do we want pair to have a copy constructor? Yeah, we want, I mean, yeah.
Otherwise, you would not be able to do
We couldn't do
this.
anything with it. It's
you couldn't do anything.
fairly useful. Therefore, what's the natural requirement for these guys? For T1 and T2? They all should have a copy constructor, because how could I copy a pair if I don't know how to copy components? Do you agree with that? Even Jerry goes along. He's a very skeptical guy. So, therefore, it has to have, now, does it have to have a destructor? Oh, you know, guys, otherwise terrible things will happen. We write a pair and, you know, get out of scope and computer melts or whatever. It has to have a destructor. And what's the meaning of a destructor of a pair? Yes. So this needs to have a destructor, and this needs to have a destructor. Do we want an assignment? What is the natural meaning of the assignment for pair?
Element-wise assignment.
Element-wise assignment. Therefore, we have a requirement that T1 and T2 have an assignment. Now, so we already figured out that we need default constructor, copy constructor, assignment, and destructor. So not one operation, but 4 operations. And there is a word for that. Okay? The types which have all 4 of these are called what? Semi-regular. Right? Regular adds equality. And we'll talk about it in a second. Now, are these operations connected, interconnected? Could I make them totally disjoint and very different? Like one of them will multiply, another one divide. Now, I could? Yes. If I want job security and a job at A9 infra team, that's what I'll do. But sorry, because, you know, the people on infra team, they don't believe in any rules. They think they're fascistic things imposed by Alex. But you see, or communist things, even worse. So now,
But I mean, so we already talked about.
Give me a simple thing which we must do, which somehow, unless we want job security and permanent employment, we want other people to assume that our pair or any other class which we write behaves in a reasonable, sensible way, yes? Now, let us write a piece of code. Let us write T.
Have we agreed upon what the relationships between the requirements?
That's what we're trying to derive. Get rid of this stuff for the time being.
Well, we have the first example here, but
Well, let's write here. You could put back, but whatever. Let us assume that for some type T, Jerry here writes Tx equal y. And then comes, let's take totally opposite of Jerry, Ryan. So here comes Ryan and says, no, I don't like this code. You know, it's our team, we don't write code like that. I'm sure he always says that, right? So Tx semicolon x assign y. He rewrote it like that. You could do that. We could do it the other way if you like. You write the original Jerry throws. But now, let me make the following claim, that in any sensible universe, these two code snippets are the same, do the same thing. There could be some performance difference, but semantically, they must be the same. Or we will never be able to touch each other's code. Because if a self-evident transformation from this to this does not work, code becomes brittle, we cannot reason about, we cannot do anything. Everybody agrees with that. Ryan doesn't. Yeah, even Ryan agrees. Okay, we're good. So we come up, here we see that however we define things, they have to satisfy, this is the semantics of this semi-regular type. So it's not just syntax. We're not just saying you have to provide these operations. They have to have certain semantics. What? These are syntactically the same.
the language guarantees that
they are the same.
That they are the same. So if I write
yes, it does. If they're of the same type.
Yes. Or these days you could write
curly braces. The preferred way now is actually write this. But we don't want to go. This is syntax. Semantically, there is an operation called copy construction. There's an operation called assignment. What I'm trying to say, they must be connected. There has to be a semantic connection between two.
They must lead to the same final state.
But this just shows that this is equivalent. Is there any broader rule which we want them to satisfy? Is it just, okay, for example, let us assume, whom should I am allowed to use Hernan for the worst examples, him being a manager. Here comes Hernan and says, this is going to be like integer, but a class containing an integer. And every time I do a construction, I'm going to increase it by 1. Should he be encouraged to do that? Is he right? Of course, if we use the general thing that we're free people and can do whatever we like, he can. But is it a good thing? Is such a class regular? Does it behave in a way people expect? What do you expect from copy construction? What do you expect? Forget all the deep stuff, forget C++. What does it mean that you make a copy? To the original, not identical. You get different but equal. No. This is very important. We shall see if you get identical, you might not like it at all. Because what you wrote here what you wrote here is give me a copy of y. That's the meaning of that. It's not an idea. I mean, so what does it mean it's a copy? Is there some way of saying it? Compare by like, how? Equal. That's not a bad idea. That is, and this is my conflict with the Standard Committee for ages. I actually claim that equality is essential. That you cannot talk about copying unless you have a notion of equality. Because what does it mean you copy? You construct a thing equal to the original. So please sit down, figure out what equality means, and define it. We'll have to talk about it. It's not as simple as you think. Nothing is simple, actually. So therefore, I used to demand that all these things take regular T1 and T2. But again, they now say it's semi-regular. Equality doesn't have to be explicitly defined. It is implicitly there because since you are copying, you have some idea of equality you're constructing. So what is this idea? You do not have equality. Nevertheless, what do you expect for a copy? The Standard Committee took equality away. Could you still talk about copying? To a predicate. There is this wonderful, wonderful thing invented by Leibniz, which sort of tells what is equality. Let's write Leibniz axiom.
If?
No, just write it x equal y. Let's write it mathematically. Implies both ways. We actually need write capital A of P. Well, capital A means it should be the other way, but we don't have. Our keyboard does not have quantifiers. Yes. Full P of x equal P of y. This for any predicate. Well, or at least it's more complicated than that. You know this great rule that no mathematical truth is named after its discoverer. So therefore, if it's called Leibniz axiom, it's probably not Leibniz. But Tarski calls it Leibniz axiom. And Tarski is a good logician. We have to believe him. So Leibniz says something remotely like that. Not quite like that. But the idea is that what we expect that for any predicate, or at least for any reasonable predicate, because we could write non-reasonable predicates. See, it's all very complicated. For any reasonable predicate, when you make a copy, it possesses the same properties, whatever your properties are.
So in other words, you made a copy. Why did you make a copy? Because there's something you wanted to do on the original, but maybe the original is no longer around. You want to do the same thing on the copy, and you expect the same result. Right? That's why you made a copy. So that's
yes. And by the way, we do these transformations without thinking. What is a common compiler optimization which relies on that? What is the most common compiler optimization people do? Themselves in the code, never mind compilers. Let's do the other way. It's called common subexpression elimination. Sort of you have common subexpression, what you do, you just use the copy twice. You assume that A plus B, if you compute it once, it's going to be equal to it again, right? So in general, there is, when we look at the compiler work on sort of over the last several decades, global optimizer work concentrates on a thing called SSA, static single assignment, where you basically see how copies propagate through your graph and sort of stop copying or do copying, depending what makes sense. So studying of copying is very, very important. So again, I claim this is the semantics of typing. So we could go and make our first change in the code.
So should we make it semi-regular or regular?
Let's make it semi-regular because
so this is, for those of you who remember last lecture, very similar to what we were talking about last time, which is you can define less than, you can define greater than in C++ independently, but that does not mean that they are some things you can define without any relation to each other. But there is something that binds them together, and so it doesn't make sense to have a lessable concept and a
grateable
concept. It's just you have some total ordering or whatever. Right? Similarly, copyable may not make sense as an independent concept because copy and assignment are just inextricably linked to each other. Right?
In Java, if you're making a hashable object, the quality and the hash function, they have a relationship. You can have a bad time.
Yes. Yes, do not match. Yes. They better match. Yes. So, of course, we still do not have concepts, but even if we do not have them in the language, they should exist in our mind. Right? Again, people tell me, well, that doesn't apply to Java. Java will never have concepts. Of course, Java has concepts. Any language, Python has concepts. I mean, they're not in the language, but what you do still, I mean, you construct something which satisfies some properties. That's a concept. Concepts is in the mind.
And you're
primarily.
thinking integral type, list of some sort, array of some sort, comparison operation. That's a concept.
These are concepts. A
you
container.
might decide, oh, I'll use this type and not that type. That doesn't change how you think about the function. You just decided that your integer ranges are better suited to the other type.
So you have to learn to think in terms of concepts, whichever language you use. Right? So here I'm jumping from bits. First I tell you the only thing important in the world are bits. And then I tell you the only thing important are concepts. They're not exclusive. So the bits give you the material out of which you construct your stuff. But in order to understand, you create a universe of concepts, conceptual universe, in any discipline, not just in programming. So we came up with the concept of semi-regular. But now, if we do this, and here comes the really sort of thing which is not quite pleasant, but we'll have to do it anyways. Now, Param wants to say pair int int. For whatever reason. It's a good pair, especially if he wouldn't put space there. You see, he's like that. He always puts spaces where we don't need them. And
this big button that,
yeah, so, but pair int int. For sure, you want equality on this. Do you agree that for pairs of integers, equality is well defined? Hernan, do you agree with that? Yeah. I mean, like pair 0, 1 is equal to pair 0, 1. And it's probably not equal to pair 1, 1. It's a different pair.
And no, I mean, so why should it be defined? I mean, let's sort of think
why
about
should
it
it
a
be?
more.
Very good
Yes,
question.
it's nice that we could define it, but why? I could very well write my code saying, if foo.first equal to bar.first. I mean, that works perfectly fine. Why do I need to define equality?
There are two reasons.
It's convenient, certainly, but
convenient for what? No, you're thinking deep stuff. Don't think deep stuff. Very basic level. I mean, the most basic level, we actually just looked just a second ago. You want equality? Nick told us why we want equality. Do you remember what you said? Oh, he doesn't remember what you said. That's good. That's how they get educated nowadays. They say something, 30 seconds, I don't know what I said. Okay, what you said, let me remind you, when we're discussing what we want copy to satisfy, you say, oh, it's self-evident. It should be equal to the original, said you. So one very nice property, we have equality. We could actually use equational reasoning when we construct copy.
You could write a test for your copy, for example, which would be inconvenient again. Or for instance, let's say you want to use some standard library function like find if.
No, find if you don't need it. Find you do need. What is the signature of find? Anybody knows? Wow, we have a bunch of great C++ programmers. Anil, come on, what's the signature of find? 2 iterators and what? And an object. And what does it find? It returns an iterator which is equal to this object. So when we write this code, how is it going to look? It's going to say, while first is not equal to last, and star first not equal a plus first. That's, by the way, the whole code. This is linear search for an object. You need equality to do linear search, guys.
And again, you could do find if, but then it's inconvenient. You can do everything without equality if you so desire by writing all the functions yourself, but it's terribly inconvenient. I mean, let's say you want to do delete. Again, I don't know if there's a
erase,
delete.
It's called erase.
No, the vectors had a delete thing, right? Erase.
Erase.
If you want to do erase, I don't know if erase takes a predicate. You could write a function that does that, but it's inconvenient. If you just write equal to, it works well with all of
Bad example. It takes an iterator, not a value.
Okay, I was talking about the abstract thing, not the specific STL stuff. Okay, go ahead.
Abstract, whatever. Do not talk about abstract erase takes an iterator.
Okay, sounds good.
In any language.
So it's, yes.
But in any case, equality is really important if you want to write code which sort of independent of pair, because equality is defined. Moreover, there is this wonderful, wonderful thing. You should always try to generalize from what you have. What do you have as your basis of abstraction? What is already given? You don't say. What is given? Your program in C, what is given to you? There is a name. Built-in types. What do we know about built-in types and equality? They have it. Right? So it would be nice if we try to assure that derived types already also have it. And there is a natural meaning of equality. What does it mean? 2 records are equal, even not pair. I'm giving to, how would we want it to be defined? You have record with field foo, bar, and baz. It's a mighty record. All the parts are equal. That's a natural definition. Yes?
So, I mean, so for instance, if we were to copy a struct in C, C will automatically give you member-wise copy, as we talked about. So member-wise equality is of the same nature. There's nothing mysterious about it. There's a clear definition for it, and the compiler could synthesize that really with no trouble.
But it doesn't.
We live in an imperfect world.
Again, here is a long battle between me and my dear language design friend, some of you met him, who sort of say, Alex, you're too theoretical, and therefore we still do not have synthesized equality. You have to write equality by hand, time and time and time again. Okay? Now, how would you write equality? Anybody knows how to write equality? Don't write equality. Let them write equality. Anybody in this class could write an equality for simple struct.
Ryan, go ahead.
Friend. Friend, that's good. That's in Swedish.
Interestingly, if you delete R from friend, you get something very interesting.
Yes.
Regardless.
New line.
Operator equal. Const. Pair ref.
No. No. It wouldn't compile. You do. With angle brackets.
Yes. No, it'll compile without it. It knows the types from explicit instantiation.
For friends?
Yes. For friends.
No, positive?
Positive.
Oh, he's done it. Maybe true. That's, okay.
X.
I didn't know that.
Const pair ref y.
No, that for sure wouldn't compile.
Oh yeah, you don't need const because it's not.
You cannot have const. It is not a member function. You cannot overload. You did, if you like, say that you take constants. That's why you say that. It's not a member function. By the way, why is it not a member function? Why equality is not a member function? Everybody thinks that member functions are good and make equality a member function. And they say, no, it shouldn't be a member function. You don't need to do that. If you make it a member function, that is not needed. Start with mathematics. It is symmetric. It is symmetric. X and Y. It's not X as some special operation on Y. Right? And you say, but does it make any difference? It actually does. For example, it's actually a terrible thing, but nevertheless, we want this terrible thing to happen consistently. For example, if you compare, you define a conversion operator, which they do in the standard for pairs, which I don't want to go into. And the conversion operator will work here on both sides. The implicit conversions will work on both sides. If you make a member function, it will only work on one side. So there will be contexts where you write some expression equal some other expression, and it works, then you change them, and it stops working. That is clearly undesirable behavior. We want the thing to be symmetric. Equality is symmetric in general, semantically, but it also should be symmetric syntactically. Right? So I'm just explaining.
Return x dot first equal y dot first. Ampersand, x dot second.
Very good. And what else? If we define that, what else do we have to do? We must define inequality, because we sort of rely on the fact that, again, this is Jerry-Ryan transformation, remember, that we want to assure. Let's show them what we want to assure after the end of the class.
Suppose you have this.
Whatever. Yeah, like that. This is good.
You should be able to transform this to, if x is not equal to y.
And they should be the same. I mean, nobody should think whether writing bang open paren x equal y or x bang equal y. They should be freely interchangeable. What would be the right thing for the language to do? Automatically. You have no right to have not equal to do anything but the negation of equal. Again, when STL was put in the standard, I wanted to demand that, and there were people on the standard committee saying, but we have cases where we want totally different semantics. And, what could I say? They won. They actually sort of still do not have that. You have manually defined it, but again, this is the definition which you would copy-paste from one place to another time and time again. How would you define it? Yes. So you could, but it's not synthesized. So remember when we talked about ordering, if you define less than, other sort of comparators should be automatically obtained, but it doesn't happen. But you have to get into a habit, first of all, you have to, whatever class you define, think about equality. And just, we had an argument with Param, but in search engine, nobody ever wants to compare two indices for equality. My answer is no. And it's a perfectly legitimate thing to compare two indices for equality. So at least somebody should stop for a second and say, what does it mean that two indices are equal? By the way, very non-trivial question. While it's trivial for the pair, it's much less self-evident for the index. Probably the broadest definition of equality, two indices are equal if they return the same match set for the same queries. But then, let me tell you, it becomes probably not effectively computable. It's too hard to figure out. So you have to, there is this wonderful, wonderful thing which you need to consider that. Right?
But in the vast majority of cases, member-wise equality is usually what you want, and it's easy to do.
Except all the cases we're going to study.
Heap allocated objects, of course, but yeah.
In data structures, it's actually not what we do. We don't do it for vector, list, deck, set, map, any imaginable other data structure. So again, what it is good for is for tuples. This is where it's good. So if you do something like that, you obviously should generalize that from pair to an arbitrary tuple. It's the same semantics. Yes? Now, what else do we need to define? Do we need to? Do we need to define constructors? Do we need to define constructor-destructor? Guys. Some of you supposedly are C++ programmers. That is, I could point to some people whose job it is to write code in C++.
Suppose I...
explicit constructor if you want to pass values for first and second. Because the only default constructor that you get is the default constructor.
No.
You get at least two constructors.
Yes.
So we talked about what we want to write
I do know.
For this, right?
That I do know. I might not remember the syntax.
Let's say I don't have any constructors.
And the default constructor.
Yes, you get two.
If we want to be able to say pair of 1, 2, we cannot do it without defining an
Well, in C++11, actually, we can.
C++11, but I said
We can.
C++03.
Yes. In C++03, we need a constructor from T1 and T2. Right?
And then once we do that, we have to define a default constructor.
Yes. Let us do, okay. We will do it in the beginning. Actually, what I recommend, if you figure out the situation with constructors yourself, but since I know that you will not, we will repeat it in the beginning of the next class. But I urge you to do it. It's a relatively simple thing, And figuring out is useful. And actually what is useful is figuring out what C++ does, but even more importantly, what C++ should do, what a language should do, because it's not necessarily the same. Yes? See, we cannot even write a pair, guys. That's
Well, we wrote, what, 25 lines?
Yeah.
Which is pretty good.
1/3 of it.
All right, see you next time.
Jerry is not impressed with our programming abilities.